Hi, Assalamualaikum and good day. Today you are going to learn chapter 3 that is on power series. Power series is a representation of a particular function as an infinite sum of powers in one of its variables. Power series is used to approximate value of a function. It can also be used to differentiate or integrate complicated functions. These are the objective of today's lesson. Hopefully, by the end of this session, you are able to explain the Taylor series and use this series to approximate functions. A power series is basically a series with the variable x in it. Generally, power series is represented as an infinite sum of Cn x to the power of n or Cn x minus a to the power of n, where Cn here are the coefficients of each term in the series and a is a constant. Taylor and Maclaurin series are very important when we want to express a function as a power series. Let's start with the Taylor series. There are two formulas to be used for this series. The first formula is known as Taylor series about the point x equal to a, or the Taylor series in power of x minus a, in which the function of fx is represented as fa plus f prime a multiplied with x minus a plus f double prime a over 2 factorial multiplied with x minus a square plus f triple prime a over 3 factorial multiplied with x minus a to the power of 3 plus so on. For each term, take the next derivative, divide by n factorial and multiply by x minus a to the power of n. The second formula is known as Taylor series in power of x, in which the function of f(x plus a) is represented as fa plus f prime a multiplied with x plus f double prime a over 2 factorial multiplied with x squared plus f triple prime a over 3 factorial multiplied with x to the power of 3 plus so on. Take note that for the second formula of Taylor's, only the variable x having the increasing power. Actually, these two formulas are the same. It's just the matter on how we represent the expansion that is either in power of x minus a or in power of x only. Refer to example 1. You need to obtain the first four terms in the expansion of cos x as a power series of x minus pi over 4. As this refers to the Taylor series, you need to determine the formula first, either using the first or the second formula. That is by looking at the given hint in the question. As given cos x as the function of fx, you need to apply the first formula of Taylor's. The other hints here is x minus pi over 4, in which a is equal to pi over 4. Therefore, the Taylor's expansion in power of x minus pi over 4 is fx equal to f in bracket pi over 4 plus f prime pi over 4 multiplied with x minus pi over 4 plus f double prime pi over 4 over 2 factorial multiplied with x minus pi over 4 square plus so on. As the question asks for the first four terms, you need to differentiate the function few times until you obtain four non-zero values for the fa and its derivative. If let's say one of the derivative is equal to 0, you need to differentiate once again until you get enough non-zero value. Given that fx equal to cos x, differentiate cos x, you will get f prime x equal to negative sine x. Differentiate again, the answer for f double prime x is equal to negative cos x. Differentiate one more time, you will get f triple prime x equal to sin x. Next, replace all the x with pi over 4. You will obtain f pi over 4 is 1 over square root 2. F prime pi over 4 is negative 1 over square root 2. F double prime pi over 4 equal to negative 1 over square root 2. And f triple prime pi over 4 equal to 1 over square root 2. So here we have 4 non-zero values. The values can be obtained using the calculator or using the right angle triangle as given follows. As you know, pi over 4 is equal to 45 degree. Tangent 45 degree is equal to 1. When you represent this in the right angle triangle, tangent theta is referred to opposite over the adjacent. If the opposite is 1 and the adjacent is 1, then the hypotenuse is equal to square root 2. As sine is referred to opposite over hypotenuse and cos is adjacent over hypotenuse, from this diagram, sine pi over 4 is equal to 1 over square root 2 and cos pi over 4 is equal to 1 over square root 2 as well. After obtaining the 4 non-zero values, substitute the answer into the first formula of Taylor's accordingly and simplify. You will obtain the expansion of cos x up to 4 terms, that is, cos x equal to 1 over square root 2 minus 1 over square root 2 multiplied with x minus pi over 4 minus 1 over 2 square root 2 multiplied with x minus pi over 4 square plus with 1 over 6 square root 2 multiplied with x minus pi over 4 to the power of 3 plus so on. The first 4 terms of cos x are shown as follows. Next is you need to evaluate cos 46 degree using the expansion that you have obtained for the cos x. To do this, you need to determine the value of x in radian first. By equating cos x with cos 46 degree, x is equal to 46 degree. Convert to radian by multiplying 46 degree with pi over 180, you will obtain x equal to 23 pi over 90 radian. By replacing all the x with this value and simplify, you will get cos 46 degree equal to 0.6946. Refer to example 2. You need to obtain the expansion of sine x plus pi over 2 until the terms in x to the power of 4. Hence, evaluate sine 89 degree 30 minutes correct to 5 decimal places. To solve, you need to determine the formula first. As given, sine x plus pi over 2 as the function of fx plus a, in which a is equal to pi over 2, you need to apply the second formula of Taylor's. The added hint is you need to find the expansion up to x to the power of 4. Thus, the Taylor expansion of sine x plus pi over 2 is referred to fx plus pi over 2 equal to f pi over 2 plus f prime pi over 2x plus f double prime pi over 2 factorial x squared plus f triple prime pi over 3 factorial x3 plus so on. As the question asks for the expansion up to x to the power of 4, you need to differentiate the function up to 4 times. When applying the second formula, please be careful. You cannot simply differentiate the function given in the question because it refers to the fx plus a. The function that you need to differentiate is the fx. As given, fx plus a equal to sine x plus pi over 2, fx is equal to sine x, in which a equal to pi over 2. Differentiate sine x, you will get f prime x equal to cos x. Differentiate again, the answer for f double prime x is equal to negative sine x. Differentiate one more time, you will get f triple prime x equal to negative cos x, and differentiate for the fourth time, you will get f 4 prime x equal to sine x. Next, replace all the x with pi over 2, you will obtain f pi over 2 equal to 1, f prime pi over 2 equal to 0, f double prime pi over 2 equal to negative 1, f triple prime pi over 2 equal to 0, and f 4 prime pi over 2 equal to 1. The values can be obtained using calculator or using graph of sine x and cos x as given follow. Pi over 2 is equal to 90 degree. From the graph, sine pi over 2 is 1 and cos pi over 2 is 0. Next, substitute the answers into the second formula of Taylor series accordingly and simplify. You will obtain the expansion of sine x plus pi over 2 up to x to the power of 4, which is 1 minus x squared over 2 plus x to the power of 4 over 24 plus so on. To evaluate sine 89 degree 30 minutes using the expansion, you need to determine the value of x in radian first. Sine 89 degree 30 minutes is equal to sine 89.5 degree. By equating sine x plus pi over 2 with sine 89.5 degree, you will obtain x equal to negative 0.5 degree. Convert this to radian by multiplying it with pi over 180. You will get x equal to negative pi over 360 radian. By replacing all the x with this value and simplify, you will get sine 89 degree 30 minutes equal to 0.99996. To check your understanding on Taylor's series, please do the following 3 questions. In the next lesson, you are going to learn about Maclaurin's series, so stay tuned. Till we meet again, stay safe and stay blessed. Assalamualaikum.